You've been there, right? Staring at a survey from a few hundred people, but you've got to make $1 million decision based on it. Talk about high stakes. That kind of uncertainty can be absolutely paralyzing. Well, today we are unpacking the exact tool that top consultants use to handle this, the confidence interval. We're going to break it all down so you can take that limited data and turn it into confident, strategic action. Let's get right into it. So, picture this. You've just presented your latest survey findings. You're feeling good. And then your boss leans in and asks, "This is great for these 500 customers, but what about all 5 million of them?" Whoa. That is a question that can make anyone start to sweat, right? Because a sample is just that, a tiny snapshot, not the whole movie. So how do you build that bridge from a small data set to a massive population? And how do you do it with a level of certainty you can actually stand behind? How do we put a number on our confidence? The answer, and here we're putting our answer first principle into action, is the confidence interval. Now, this isn't some single magic number. No, it's a calculated range of possibilities. Think of it like a target zone. It's a range where we can be super certain the true answer for our entire population is hiding. This is how we go from making a simple guess to a defensible strategic estimate. It's how we take that fuzzy uncertainty and turn it into a variable we can actually manage. Okay, so here's our game plan. We'll kick things off with the big idea, the certainty principle. Then we'll nail down the core concepts and clear up some common mix-ups. After that, we're diving into the toolkit, first for means, then for real business problems. And we'll wrap it all up with a challenge. Let's do this. All right, first things first. Let's talk about the big idea here. Think about political polls you see during an election, right? They can't possibly ask every single voter who they're voting for. So what do? They take a sample. And the confidence interval is what lets them say something like, "We think candidate A is going to get 52% of the vote, plus or minus 3%. See that? They're using a small group to guess what the entire country will do. And that confidence interval is how they tell us exactly how much uncertainty is in that guess. That's the whole game right there. Okay, let's lay the groundwork. We got to get our definitions straight. Just like building a house, you need a solid foundation. And these core concepts are it. Getting these right is absolutely non-negotiable before we start crunching any numbers. So let's lock them in. All right, first up, and this is probably the most important distinction we'll make today, the interval versus the level. They sound the same, but they're not. The confidence interval is the actual range of numbers we calculate. Like between 23.1 and 24.9 years old. That's the what. The confidence level is how sure we are. It's the percentage, usually 95 or 99%, that tells us how certain we can be that the true answer is somewhere in that range. So one is the range itself. The other is our confidence in that range. Totally different things. So you might be wondering, what makes that range wide or narrow? Well, that's where the margin of error comes in. This is literally the plus or minus part you always hear about. We calculate it using our confidence level and how many people we surveyed, and it basically tells us the wiggle room we have around our sample's average. A small margin of error, that means a super precise estimate. A wide one? Well, that just means we're not quite as sure. Okay, this is super important. Any pro will tell you that knowing what a tool can't do is just as critical as knowing what it can do. This is what separates the experts from the amateurs, because it stops you from making huge mistakes. So let's get crystal clear on what a confidence interval is not, by tackling two really common mix-ups. First, let's talk about confidence intervals versus prediction intervals. A confidence interval, what we're focused on, is all about finding the range for the average of the entire population. A prediction interval, that's a completely different beast. It tries to predict where the very next data point will land. See the difference? One's about the group average, the other is about a single future individual. Big difference. And second, please don't mix up confidence intervals with control limits. You see control limits all the time on those charts in factories or operations. They're for monitoring a process right now in real time to see if everything's running smoothly. A confidence interval is for looking back at data you've already collected. It's a tool for analysis. So one is for keeping a process on track, the other is for understanding your data. They're just different tools for completely different jobs. All right, foundation's built, the theory is solid. Now it's time to get our hands sturdy and open up the toolkit. This is where we stop talking about it and actually do it. We're going to see exactly how these intervals are calculated, starting with the most common job of all, finding the confidence interval for a single population mean. Let's jump into our first problem. We've got data from 500 students. Now, the magic number here is 500. Why? Because of something amazing called the central limit theorem.
Basically, it says that when your sample is big enough, and a good rule of thumb is over 30, your data is going to start looking like that classic bell curve. And that is the green light we need to pull out one of the most reliable tools in our kit, the Z-score.
So to use our Z-score, we need what's called a critical value. It's just a number that matches the confidence level we want. In our problem, we want 99% confidence. So we just look it up on a standard Z-score table, like this one. And what's cool is that these numbers don't change. For 99% confidence, your Z-score is always 2.576. For 95%, it's always 1.96. Memorize these, you'll see them everywhere. Okay, let's put the puzzle together. Step 1. We grab our critical value for 99% confidence, which is 2.576. Got it? Step 2. We calculate the margin of error. The formula looks a little scary, but it's just our Z-score times the standard deviation, which is 8, divided by the square root of our sample size, 500. Plug that all in, and you get 0.922. And step 3 is the easy part. Just take your sample average of 24 and plus or minus that margin of error. And boom. There's our answer. Our 99% confidence interval is from about 23.1 to 24.9 years. So what does that actually mean? It means we are 99% sure that the true average age of all first-year students, not just our sample, is somewhere in that range. We've done it. We've built that bridge from our little sample of 500 to make a really solid statement about the entire population. Okay, great. But what happens if your sample is tiny, like under 30? Here we've only got 19 tennis balls. In this case, that trusty Z-score we just used, we can't use it. We've got to pull a different tool from the kit, one that's built specifically for these small sample situations. It's called the T-score. Now, the process is pretty much the same, but there's one tiny extra step. Because our sample is so small, there's a bit more uncertainty, right? We have less information to go on. To account for that, we calculate something called degrees of freedom. It sounds fancy, but it's just your sample size minus 1. That's it. It's just a little adjustment for that extra risk. So for us, 19 minus 1 is 18. We use that number 18 to find our critical value on a t-table, which turns out to be 2.101. After that, the steps are exactly what we did before. And there's our result. We can now say with 95% confidence that the real average weight of all the tennis balls made in that factory is between 58.008 and 58.392 grams. See, it doesn't matter if your sample is big or small, as long as you know which tool to pull from the toolkit. Okay, finding the average of one group is cool and all, but where this stuff really gets powerful is when you start comparing two different groups. This is what businesses do constantly. I'm talking A/B testing a new website feature, seeing which marketing campaign worked better, or, like we're about to do, comparing two different groups of people. So here's a classic business case, or in this case, a medical one. We want to know, is there a real, statistically significant difference in blood pressure between smokers and non-smokers? We've got our two groups, each with its own average and its own variability. The key question isn't about one group's average, it's about the difference between them. So our strategy is to build a confidence interval, but not for a single average. We're building it for the difference between the two averages. So we start with the difference we can see in our sample. 138 minus 135 gives us 3. Now, the formula for the margin of error gets a little hairy here because you have to factor in the messiness of both groups, so we're just going to skip to the result. That combined margin of error works out to 6.19. So we take our difference of 3, and we do our plus or minus 6.19. And check this out. This is the big reveal. Our final interval runs from negative 3.19 all the way up to positive 9.19. What's the most important number in that range? 0. Think about it. If the range of possible differences includes 0, that means it's totally plausible that there is no difference at all. So what's our conclusion? With 95% confidence, we have to say that we can't prove there's a real difference between the two groups. And that is a huge data-driven insight. It stops us from making a claim that the data just doesn't support. Wow, okay, we have covered a ton of ground. We defined everything, we calculated for big samples and small samples, we even compared two different groups. Now, it's time for the final challenge, the boss level. We're going to tackle a real question from a Six Sigma black belt exam. Here we go. The question is, what's the 95% confidence interval for a 20% absentee rate in a department of 30 people? Now, this is a little different. We're not dealing with an average, we're dealing with a proportion, a percentage. That means we need a slightly different formula from our toolkit. So take a look at the options. How would you even start to solve this? All right, let's break it down like a consultant. First, what do we know?
We know p, our proportion, is 0.20. We know n, our sample size, is 30. And we know we want 95% confidence, which means our z-score is that familiar 1.96. And the formula we need is the one right here on the screen. This is the standard one for proportions. Okay, now we just run the play. First, we tackle that square root part of the formula, the standard error. That comes out to 0.073. Next, we multiply that by our z-score of 1.96 to get our margin of error. That gives us 0.1431, which is basically 14.3%. And for the final step, we take our 20% and add and subtract that 14.3%.
Let's do the math. 20% minus 14.3% is about 5.7%, so let's call it 6%. And 20% plus 14.3% is 34.3%. Let's call that 34%. So our range is 6% to 34%, which is option A. Yes, we did it. We took all the concepts, picked the right tool, and solved a real-world exam question. That's what this is all about.
So let's wrap this up. What's the big takeaway here? Confidence intervals are your tool for turning that foggy, I'm not sure feeling into a calculated, defensible range. They are the bridge that connects your small sample to the big, wide world. So the next time you're looking at a piece of data and you have to make a call, you now have the framework to see beyond just a single number and understand the true range of what's possible. So my final question to you is, what decisions are you going to make with more certainty now?